7. Let's see. Sine, cosine, tan. All right, so label opposite, hypotenuse, adjacent. Sine is O over H. O over H, 1 over radical 5. Cosine is adjacent over hypotenuse, 2 over radical 5. And tangent, opposite over adjacent, 1 over 2. It's a half. Okay, that's it. All right, last one. Number 8. Do it over here. All right, so we have our O is across from the theta. H is across from the right angle. Adjacent. Sine is O over H, 5 over 4 radical 2. Cosine, A over H, radical 7 over 4 radical 2. Tan, O over A, 5 over radical 7. All right. So that's the basic idea of labeling. Okay? Okay, so now slightly harder. Find the ratios for sine, cosine, and tangent. Why are these harder? You're missing a side. So I made this up because you have to do the Pythagorean theorem and then do the problem. So 6 squared plus 7 squared equals c squared. Right? 42 plus 49. What is that? 91. So c is square root of 91. So a lot of times, honestly, that's it. Just radical 91. There's nothing. I don't think anything goes into that. All right. So sine theta, cosine theta, tan theta. All right. So what's my h? That's my radical. What's my o? Cross from the angle. Whatever's left over is my a. Sine, opposite over hypotenuse, 7 over radical 91. Cosine, 6 over radical 91. Tan over A, 7 over 6. Done. All right. All right. Again, we have to find the missing side. Let's do it over here. So that's either your A or your B. We can actually call it A since that's the adjacent side anyways. Let's call it A. A squared plus 11 squared equals 18 squared. A squared plus 121. I have no idea what 18 squared is. 324 minus 121. A squared is 203. And that is not a perfect square. Okay. All right. So now we are going to write sine, cosine, tangent. Okay. So this is our A. Where's our O? It's our 11. H. Sine, again, is O over H. Sohcahtoa. 11 over 18. Cosine, adjacent over hypotenuse, radical 203 over 18. And tangent, opposite over adjacent, 11 over radical 203. Okay. Okay. Now, number 11. If sine of theta is 12 over 13, find the value of tan theta. Okay, so notice that all you have is the fraction. What's that fraction represent, though? What is sine of theta equal? Remember, sine of theta is opposite over hypotenuse. That means if I have a right triangle, that my opposite is 12 and my hypotenuse is 13. Okay, so what I have to do is I have to find the adjacent. Well, that's just the Pythagorean theorem. If you look back, we did this one already. This is a special triangle, and I really recommend you memorize it, 5, 12, 13. It's one of the most popular right triangles. Okay, So now that I have that, what's tan of theta going to equal? Opposite over adjacent, 12 over 5. And that's the answer. You're done. Okay? So you don't have to do everything. You just have to find the missing side. Right? Okay. Tan of theta is a half. Again, I always draw my triangle the same, just out of habit. Right? Tan is opposite over adjacent. O over A. Now I have to do Pythagorean theorem to find that missing side. Right? So I'm missing my c. So 1 squared plus 2 squared equals c squared. 1 plus 4, 5 equals c squared. So c is radical 5. Okay. So now I can find my cosine. Cosine of theta is adjacent over hypotenuse. What's adjacent? Is right there. This is my opposite. This is my hypotenuse. So adjacent 2 over radical 5. And we're done. Okay. Pause the video. Do the last one on your own. All right. This time I have cosine. Cosine is adjacent over hypotenuse. So my 7 is my adjacent. 10 is my hypotenuse. We do Pythagorean theorem. 10 squared equals a squared plus 7 squared. Let's see, 100 minus 49 is 51. So a is radical 51. Okay, so I'm going to put a radical 51 here.